Good morning. Before we have class today, I want to go ahead and film an example for you to reference for our complex forces problems. So I have a problem that's not in your problem set in front of me. It says a 3-kilogram box is pulled along a rough surface with a tension force of 15 newtons. If the coefficient of friction is 0.22, then what is the acceleration of the box? So this is kind of a hard problem because I didn't give you any of the values for force gravity. I didn't give any values for force normal. I didn't give barely any information on force friction. The only thing we know is that force of tension is 15. So remember our steps for calculating. I have our steps in front of me. We want to create a free body diagram. We want to write a sum of the forces equation for both directions, remembering that if it's accelerating, then our sum of the forces is mass times acceleration. If it's not accelerating, then our sum of the forces is equal to 0. We want to be able to determine our knowns and unknowns. So what do we know? What do we not know? Plug in our formulas, which I'll go through the steps on that. Solve our equation algebraically first, plugging only zeros in. And then after we have our expression, then we can plug in our numbers and then write down our final value with units. So let's go back to our problem. I went ahead and made our free body diagram just for the sake of time, but I know it's tension, pulling, I know it's 15 newtons. I don't know any of these other forces, but I know that it's on a surface, so there is a force normal and it's going up. And I know that it's on Earth, so there's a force gravity pulling it down. And I know since that there is friction, because it says rough surface, then I know that the friction is opposing the motion, because it does say that it is accelerating. So let's go ahead and do our sum of the forces equations. So our sum of the forces in the y direction is going to be Fn minus Fg. Oops, that's a minus, not equal. Minus Fg. And that is because force normal's up, force gravity's down. That's the vertical direction. And that is going to equal 0. It is not accelerating in that direction. We need to remember that. Some of the forces in the x direction, that is going to be our force tension. This tension is to this direction. I'm so bad at this. This direction, which is our positive direction. And then the other direction is force friction, which is our negative direction. So it's going to be minus F. And this is going to equal mass times acceleration, because it is accelerating in our horizontal direction. Okay, those are some of the forces equations. Now we are going to make our algebraic expression. So before we do that, I forgot to do this. What are we solving for? You have this box in your practice. We're solving for acceleration. So we need to get A by itself. Okay? So now we got to make our expression. I'm going to go ahead and plug in some formulas. I give you formulas at the top that you can use. So since I know that Fn minus Fg is equal to 0, I can go ahead and say that Fn is equal to Fg, right? If I move that G to the other side, then that 0 goes away. It's just moved to the other side. And I can go ahead and plug in my formula. So I know that Fn is equal to, Fg is equal to mg. So I can go ahead and say Fn is equal to mass times gravity. Okay, first steps. Now let's start to look at that sum of the forces in the x direction. So I see Ft minus Ff equals ma. So I want to rewrite that and get A by itself. So I'm going to insert an equation for this, because what I want to do is, since there's this m multiplied by the A, I want to divide the m to the other side. So I want a new equation, and I'm going to want a fraction, because what I'm going to say is that force tension minus force friction divided by mass is going to equal acceleration, right? Now, you can't stop here because I don't have force friction yet, so I have to keep going. So even though I do have A by itself right now, I need to plug in something for FF. That's why it's important to know that FF is equal to mu times Fn. So I'll just go ahead and paste that down here so that I know that. And then I can say, I know what Fn is, that's mg, so now I can just say FF is equal to mu times mass times gravity, because mu times force normal is mass times gravity. So I'm just plugging in mg for force normal right here. That's all I'm doing. Great, so now I can put in mg and for FF in this expression. So I'm just going to copy paste it. And instead of FF, I am going to put mu mg. All of these values I know. I know force tension, I know mu, I know mass, I know gravity. Now I can find acceleration. So now I'm going to plug in my values. So I'm going to do an equation again just because of that fraction. I'm going to put the A on the other side. So I can say A equals, I've got to plug in a fraction. I've got to plug in my FT value, that is 15 newtons, minus my mu value, which is 0.22, multiplied by my mass, which is 3, multiplied by gravity, which I'll give you up here, and that is 9.8 meters per second per second. So 9.8 meters per second per second. Notice how I'm putting my units when I have them. See, I forgot already. In my expression, just so I can cancel out my units if I need to later. Then I'm going to divide it by mass, so divide it by 3 kilograms. And when I plug this into my calculator, I actually find that acceleration is equal to 2.8 meters per second per second. Now I rounded, okay? I rounded to the 10th place, the 100th place is fine. You can round to whatever, it doesn't matter to me. But 100th place, 1000th place, those are good spots. So I already went ahead and did my next step actually, which is my final answer. So I'm actually going to just paste this here instead, so it's in the right spot. And my final answer is my acceleration is 2.8 meters per second per second. Now let's say I'm trying to get exceeding on my free body diagram learning goal. Well, then I would have to actually go back up here and fill in some of that extra information. So force to normal, see if you stop here, this would be meeting, right? Like I know you can do it, but now I know my values for everything. So I know that my force of gravity is 3 times 9.8. So that's going to be 29.4 newtons. Same with force normal because they are equal. And then that force friction, that was going to be equal to 29.4, our force normal, multiplied by our coefficient of friction, which is 0.22. So 0.22 times 29.4, and that is going to be 6.47. That looks prettier. Great. Save and close. This would be an exceeding, right? You have added all of your values and made a quantitative free body diagram. You have shown all of your work, and you have given me a final answer with units. This would be exceeding, okay? I know these problems are kind of hard. That's why we're taking 2 days to do it. But if you kind of use this video as a guide, if you ask a couple questions, make sure you have everything done for our discussion. You should be able to do it. I have good faith. Okay. See y'all in class. I can figure out how to stop this.